In the late 20th century, scientists discovered a gaping hole in the Earth's ozone layer, a protective shield that shields us from harmful ultraviolet radiation. This revelation led to widespread concern as the ozone layer plays a crucial role in maintaining the delicate balance of life on our planet. But the remarkable journey of resolving this problem began with cutting-edge research, diplomatic negotiations, and global cooperation. The ozone hole, primarily located over Antarctica, was caused by the release of certain chemicals known as chlorofluorocarbons, CFCs, into the atmosphere. These chemicals were commonly used in refrigerants, aerosol propellants, and as solvents. Once released into the atmosphere, CFCs would rise up into the stratosphere and undergo a chemical reaction that depleted the ozone layer. The significance of the ozone hole became evident in the 1980s when scientists started measuring a decline in ozone concentrations. In 1985, the British Antarctic Survey, led by Joe Farman, first reported the worrying phenomenon. This sparked urgency and triggered a global response to tackle the issue. Scientists and researchers from different countries collaborated to bring attention to the problem. The discovery of the ozone hole spurred extensive research and the gathering of vital data. Scientists conducted experiments, monitored atmospheric conditions, and analyzed the impacts of the ozone depletion. As evidence mounted, calls for action grew louder. In 1987, an urgent international response came in the form of the Montreal Protocol on substances that deplete the ozone layer. This treaty, signed by 46 countries, aimed to phase out the production and use of ozone-depleting substances. The agreement provided a framework for countries to work together in reducing harmful emissions that were damaging the ozone layer. One of the key elements of the Montreal Protocol was the cooperation between developed and developing nations. The agreement recognized the different levels of technological and economic capabilities among countries and provided financial and technological assistance to developing nations in their efforts to reduce ozone-depleting substances. The reduction of CFCs and other ozone-depleting substances was not an easy task. It required a substantial shift in manufacturing processes, the development of alternative chemicals, and the retrofitting of existing equipment. Governments, industries, and scientific communities had to come together to find innovative solutions.